This is just an example, the question related to the exam. Like the following figure shows a IV graph for a current against a potential difference for a filament. Explain why the graph has um, such a shape. What is the reason for that? So as you can see, this is a structure answer because it will never change irrespective of what scenario they give the question. So as we increase the potential difference, what will happen? The current will also increase. When the current increases, it produces more heat energy because current is having three effects. It has heat effect, heating effect, magnetic effect, as well as chemical effect. So whenever there is a current in through the wire or through the component or a device, it always produces heat energy. That's why, like if you're charging a mobile phone for a very long time, it also become hot. Or you're using any electronic device for a very long duration, its temperature increases because the flow of the charges always produce heat energy. So as the temperature increase, what will happen? The temperature of a filament increase, then the resistance of a filament will also increase. And why the resistance of the filament is increasing? Because there is more collision, there is a greater lattice vibration, so more collision between the electrons and the lattice. Is it clear, this one? Then we have the thermistor or the LDR or the light dependent resistors. What are thermistor and LDR, light dependent resistor? Both are semiconductor. So as a result, light dependent resistor, or we also say they have a negative temperature coefficient. Like if you usually what happen when we increase the temperature, resistance increases. But for thermistor, it is opposite. For a thermistor, what will happen when there is more energy or if we increase the temperature, its resistance will decrease. And same thing for a light dependent resistor. It's also a semiconductor. When more light or we have greater light intensity, the resistance will be low. But if it is dark or at night, the the light intensity is less. Like the intensity of a light here, the light which falls on the LDR is less. So as a result, it will have a high resistance. And same thing for a thermistor. When the temperature is low, when the temperature is low, the thermistor will have a high resistance. They are inversely proportional. Where we can use them, we can use in a potential divider circuits. So we can also explain this in terms of the transport equation, like why for they can ask for thermistor or they can also ask for LDR and using a transport equation why the resistance is changing. So example, we have a negative temperature coefficient thermistor. Negative temperature coefficient here refers to if you increase the temperature, its resistance will decrease. So, and it's a semiconductor. So using an equation, the transport equation, explain why its resistance decreases if we increase the temperature. So what will happen when a temperature is increased? More electrons can break free from the atom and they can participate in a conduction. This is what happened in a semiconductors. What happened in a semiconductors that the semiconductor silicon or germanium. So because of the heat energy, heat or a light energy, as this is thermistor, so we'll use the term heat, but it can be light as well. So due to the heat or the light energy, more electrons and hole pairs are created. When the light or the heat falls, it will knock out the, like remove the electron, absorb that, and as a result, it produces more electrons. So it means what will happen to the value of the N? The value of the N is increasing. And we have to use a transport equation. I is equals to N A V Q. Q is a constant, the charge, A is a cross-sectional area, that is also constant. So we have, it means I will be proportional to either N and V. But when the temperature increase, what happened to the drift speed? The drift speed decreases. N is the number of the charge in a unit volume or the charge density. How many charges are present in a unit volume or a charge density? So as a result, more electrons are more as the temperature is increasing, the drift velocity will decrease. So, but the increase in the number of the charge carrier is more than the decrease in the drift velocity. That's why the overall current will increase. And if the current is increasing, it means the resistance is decreasing. So, how we relate here, when the temperature is increased, more electrons can break free from the atoms and they will participate in a conduction. So, this means that there are more charge carriers, and so the current should increase and the resistance decrease. But two things are there. One is the drift velocity. Drift velocity always decreases with temperature. If you increase the temperature, the drift velocity will decrease as there is more random motion. So drift velocity is decreasing, but the number of the charge carriers are increasing, and that increase is more than the change in the drift velocity. That's why the current will increase. Is it clear, this one? Then this is a word example regarding the power. We discussed the last session about the formula of the power. So the main voltage of a household electricity is 230 volts and a light bulb is labeled 230 and 40. How much energy will it consume if it is open or switched on for a 1 hour? So, and what is the current? So energy, if we need energy is power multiplied by time. So power is given 40 and the time duration is 1 hour. So we multiply, convert into seconds. So we got 144,000 joules or 14.4 kilojoules. That's the energy which it consumes. Then if we need the current, current is we can use a formula R is V over I, but resistance is not known here. So we can also use P equals VI. So if we need an I, it will be ratio between the power and the voltage. So just divide them, you will find the current. And another, express the power in dissipation, and this we did in the last session. Now, resistance, when resistors are there, a short derivation, in exam they asked this to derive a formula for to find the combined resistance in series and combined resistance in parallel. So let's take like two different circuit. One is series, another one is a parallel. So if we have a series resistor, two or more resistors are connected in series, and we want to derive a formula. So this is R1, R2, and R3, and they're connected in series. So characteristic of the series circuit that it is always having the same current. The current, if I is from the battery, the same current will flow through each component. But the voltage will divide the total. If the total voltage is V, the voltage here is V1, total here V2, and here it will be V3. So we can say the total voltage, and we are actually using a Kirchhoff's second law. That what is the Kirchhoff's second law? The total EMF will be or equals to total potential difference in a closed loop. So total EMF is V and total potential difference is V1 plus V2 plus V3. And V is equals to IR, the Ohm's law. So this will be equals to I and the total resistance of a circuit. The current is here I and the first resistance R1. This will be R2 and this will be R3. We take I common. When we take I common from both sides, so this will be R1 plus R2 plus R3. I will cancel with I, so the total resistance of a circuit will be the sum of individual. So it will be R1 plus R2 plus R3. So whenever two or more resistors are connected in series and we want to find the combined resistance, so we will the number of the charges which are passing, that's R is equals to R1 plus R2 plus R3. That is in a series circuit. Look, the concept, there is one thing like student ask a question that if we have a resistor then the current, this is a question from the student. If we are having a resistance and the current here is 2 ampere, then what should happen? That this 2 ampere should turn into 1.5 ampere. That is the question of the student. That the current should decrease because this is a resistor which resists the flow of the charges. But actually what happened, what is the effect of the resistor is that it's not only limit the current which enter the resistor and going out, it limit the current which is coming out from the battery. So when you add a resistor in the circuit, it's not like the resistor limit the current which is passing through. It limit the current which enter the circuit. So the from the beginning, the resistor will reduce the current to a low value. So the same current will flow through it. So it's not like the current which enter the resistance and the leave the resistor will be different. It will be same because the effect of the resistor in the circuit is that it restrict the flow of the charges from the beginning when it enter the circuit, not when it is passing through it. So this is a misconception that resistor limit the current when it enter and then different current will come out. No, from the battery it will limit the current. So when I was explaining the idea that let's say five charges are entering and two charges are able to move out, I was giving an example, the concept. But actually what happened from the battery, from the beginning, the two charges will enter and the two charges will leave. Because what is the effect of this resistor here? The from the battery, five charges to come out, but it restrict the charges from the battery, not in the wire. So it restrict the charges from the beginning. But to explain the idea, I was showing the charges entering and leaving are different. If you have two or more resistors are connected in parallel, two or more resistors are connected in parallel, and we want to find like this is R1, this is R2, and this is voltage here is V. So the current here is I. The current will break down into branches I1 and I2. So now we'll use a Kirchhoff first law. According to Kirchhoff first law, the total current which enter the circuit will at any point of or any node of a circuit will be same as going out. So the current which is going in is I and the current which is going out is I1 and I2. And V is equals to IR. So if we need I, it will be equals to V over R. So here it will be V over R. Here they will have the same voltage because in parallel the voltage is same. So it will be V over R1 and this will be V over R2. When we take a V common and cancel out, so V will cancel with V. So we can say 1 over R is equals to 1 over R1 plus 1 over R2 and so on. So you can see when two or more resistors are connected in parallel, the combined resistance of the circuit will decrease. So if we want to reduce the total resistance of the circuit, the combined resistance, we connect the resistors in parallel. And if we want to increase the total resistance of the circuit, we connect them in series. Is it clear, this concept? So you should be able to derive these formulas for resistors in parallel and in series. So if you want to work out the combined resistance, these two are connected in parallel. So it will be a product divided. You can you can use a formula 1 over R is equals to 1 over R1 plus 1 over R2. And then after taking a LCM, it will be 1 plus 1. So 1 over R is equals to 2 over 100. Or we cross multiply because we need R. So R will be 100 divided by 2, which is 50. This is one way of doing the question. There's another way when two resistors are connected in parallel, so only for two. When the two are in parallel, you can take a product divided by sum. So 100 into 100 divided by 100 plus 100. So this will be 10,000 and this will be 200. So this will cancel with this, so 2 and so we'll get 50. But remember the product divided by sum is only valid for two resistors which are connected in parallel. So when two are in parallel, you can simply use the product divided by the sum. But if there are more parallel, like three are there, then you cannot use this formula for product over sum. So this will be 50 and this 50 is now because the combined resistance of the 200 ohm resistor. So this is 50 ohm and this 50 is connected in series to 80 and 150. So we just simply add them. So 50 plus 80, 130 and 130 plus 150. So 280 ohm will be the combined resistance of this combination. Here two are connected in series first. So we add them. So we got 230, the combine of these two. And then they are in parallel. So we can use a product over sum as we are considering two. Or we can also use 1 over RT is equals to 1 over R1 plus 1 over R2. Both ways are acceptable. There's a word example. Find the current flowing through each resistor and the battery in the following circuit. The current flowing through R3 and through the battery will be same because from the battery the current I is flowing that will divide in the branches and then again it will recombine and then goes out the same current. So we can use a formula like first we find the combined resistance of the circuit. So 10 ohm, 10 kilo ohm and 10 kilo ohm are in parallel. So combine of these two will be 5 kilo ohm. How we work out? You can use, if two are there, you can use a product divided by sum or you can use 1 over R1 equals 1 over R2 plus 1 over R equals 1 over R1 plus 1 over R2. So this will be 5 and this is 8. So when you add, you got 13 kilo ohm. That's a total resistance. We know the total resistance and we know the total voltage. So we can use a formula V equals IR. So the current, the total current will be total voltage over total resistance. So 9 is the total voltage and the total resistance is 13 kilo ohm. So 13 into 10 to the power 3 ohm. So we got 0.69 exponent minus 3 or we can say 0.69 milliampere. And then we need the because we need the current through each. So we got the total current and that total current will be divided. Like if we got 0.693, 0.69 ampere, milliampere. So because these two resistors have the same resistance, so the current will divide between them. The total current will divide between them. So it will be 10 and 10 ohm identical resistors are there, so the current will divide evenly. If they were different resistance, then uneven division will be there. How the total resistance become 13? That is the total circuit resistance. 10 kilo ohm and 10 kilo ohm are in parallel. So we use a formula product over sum. So it will be 100 divided by 20, which is 5. So means combined resistance of these two is 5. So combine of these two is 5. And this 5 kilo ohm and 8 kilo ohm are in series. So to get the total, we add them. So 5 plus 8 makes 13. That's how it is done. Is it clear, this example? Any doubt in this? Next example, a toy electric powered ambulance. In a toy electric powered ambulance, electric motor and a speaker as an alarm is connected in parallel. So it's connected in parallel to a 1.5 AAA cell that are used as a power source. When the ambulance is in operation, the electrical current passes through the speaker and the motor is zero point 0.1 and 1.1 respectively. So they are connected in parallel. So, . And what it consists of? It consists of a motor. So we can write M. Motor symbol is circle with M, and speaker is there. So you can use a symbol for a buzzer, and a motor connected in parallel. The current in the speaker is 1.1 ampere, and the current in the motor is 1.1 ampere. And it is operated by 1.5 AAA cells. We need the power of the toy ambulance and the resistance of the speaker. So this the current in the speaker is zero point 0.1 and the current in the motor is 1.1. So what is the total current? 1.2. So 1.2 is the total current which enter the circuit, and voltage of the supply, the EMF of supply is 1.5, and there are two 1.5 volt cells are there. So each is 1.5, but the total will be 3 because like two cells are there. Each cell is 1.5. So this is 1.5, this is also 1.5. So the total EMF will be 3. That's why it is used 3 here. So 3 into 1.2, we got 3.6 watt. That is the total power of this ambulance or the circuit of this ambulance, which include a speaker and a motor. Then we need the current in the speaker. So we need the current speaker as a connected in parallel. So this will also have 3 volts and this will also have 3 volt. So if we have the voltage and current, so use the formula V equals IR. So, or if you need the resistance of the speaker, so resistance will be equals to voltage divided by current. Voltage is 3 and the current is 0.1. So 3 divided by 0.1, we got 30 ohm as a resistance of this speaker. Is it clear, this one? This example, any doubts? How is the voltage same? Because they are connected in parallel. The characteristic of the parallel circuit that the voltage is same. In parallel component, the voltage is same. The current is different. And in series, the current is same and the voltage divide. That's the characteristic of the circuit. That when they are connected in series, the current is same, voltage is divided, where in parallel, the current is divided and the voltage is same. This is a basic characteristic of the circuit.